Another example that we have here that appears to be quadratic is in the form of 2x minus the square root of x minus 10 equals 0. And I'm going to rewrite this one right now just to help us understand what we're seeing. 2x to the first power minus x to the 1/2 power minus 10 equals 0. I hope you remember that we're not seeing anything new here. I can change from radical world to exponent world back and forth. When I do this, I see that this middle term is the square root of this first term. So when that's the case, I can use the substitution pattern here. So I'm going to let u equal, in this case, x to the 1/2, and then u squared. If I square this term, square that term, I get u squared equals x. Just as a little short-term substitution. So that's being the case then, I'm going to put in here 2 u squared minus x to the 1/2, which is a u, minus a 10 equals a 0. You following along? Okay, now what we need to do is factor this guy down, either using the quadratic or see if it factors cleanly. Let's see if it factors cleanly first. Five and 2's work. I got to put a 5 right there and a 2 right there. -5 plus a 2. All right, so 2u minus 5 and u plus 2 equals 0. Let's find out what u equals. 2u minus 5 equals a 0. 2u equals 5. U equals 5/2. And then over here, u plus 2 equals 0. U equals -2. So I found out what u equals, but again I was asked for in the original problem, what are my solutions for x? So I'm going to substitute back in u, which is x and x to the 1/2, equals 5/2. And over here I have x to the 1/2 equals -2. Well, I don't know what x to the 1/2 is, but I do know what x is. Or that's what I want to find out. So how do I get this to be x? Well, let's square both sides. X to the 1/2 squared is just x. And then 5/2 squared, 25/4. And on the other side, square both sides, I get x. 1/2 squared is 1 equals -2 squared equals a 4. So there are my two apparent solutions. X equals 25 to the 4th or 25/4 and x equals 4. One thing that's always a good idea is to check your solutions, especially with quadratics. Not so much if we made a mistake, although that's a great reason why we want to check our solutions, but sometimes extraneous solutions can be introduced into the problem when we're squaring. So what I'm going to do is go back to my original problem and input x to the 25/4 and x to the 4th and see what happens here. So let's go 2 times 25 to the 4th, or 25/4, minus the square root of 25/4 minus 10 equals 0. Now I don't want to get too far off the board so you can see that. So 2 times 25/4 is actually 25/2, minus the square root of 25/4, which is 5/2, minus 10 equals a 0. 25/2 minus 5/2 is 20/2, minus 10 equals 0. 20/2 is 10. So that's a true statement. 10 minus 10 equals 0. So I know that x equals 25/4 is a solution. Now what about x equals 4? Well, let's put that back into my original equation. 2 times 4 is this equation up here that I'm working with. 2 times 4 minus the square root of 4 minus 10 equals 0. 2 times 4 is 8. Minus 2 minus 10 equals a 0. I get 6 minus 10 equals a 0. Minus 4 equals a 0. Minus 4 has never equaled 0 as far as I know. So therefore, I know that this solution, x equals 4, is not a solution. It's called an extraneous solution or an apparent solution. And those will pop up from time to time, so be aware of those.